I'm really happy to be here tonight at Remix Conference. It has been a while since we've done an in-person conference, so thank you for having me. I'm Sébastien Morel. I'm CTO at Crystallize, and I've been a backend developer for since 2003. I'm French, you can hear that. I'm living in San Francisco, California. I love open source. I'm a maintainer of many projects, and I joined the DAT club a year ago, so this is also some great year. And yeah, so I'm working at Crystallize. So a quick word about Crystallize. Crystallize is an e-commerce toolbox that enables you to build your e-commerce project. And beside all those features, we are focusing on providing a sexy UI for the marketing people and the sales people building your e-commerce. But we are also focusing on providing crazy fast API endpoint using GraphQL. We can discuss tomorrow or tonight about Crystallize. Today, we're going to talk about performances, and performances apply to e-commerce project. So let's start with the basics. We have front-end performance optimizations, right? So all that stuff is really clear for you probably. You've heard about it before. Those are front-end optimization, really important for Google page speed, for the SEO, to get your page loaded as fast as possible. This is not the subject of this talk, but I just wanted to mention it because when we talk about performance, we need to talk about the loading of the page, right? But when we are playing with Remix, we have a server, right? This is what it's cool. So when we have a server, we need to protect that server. And we also need to use it for the cool feature that the server is providing. So of course, we have the time to first byte, which must be as fast as possible. You need to handle minification, packing, compression, sizing the image correctly. But it's not because you have a backend, the server, that you should not consider using the edge and using HTTP cache or HTTP2 and build an architecture that is mostly asynchronous. So for the front end and most of the back end, Remix got your back, right? And we're going to dive a little bit more into how to build an e-commerce project with high performance. So what about e-commerce project? Why are they so different from other projects, performance-wise? First, it's simple. E-commerce projects are all dynamic. Everything is dynamic in an e-commerce project. So key features of an e-commerce project are catalog, product variation, stock, discount, cart, order management. If you just think about stock management, every time you have an order, every time someone is placing an order, you need to update something because it has to be updated on the catalog. You want to provide, the stock that are available on your catalog. So you need something highly dynamic. So to build this using Remix, we are back to the standard of the web, right? We're going to need a strategy for three things: the rendering, for how to deliver the application. So we're going to talk about HTTP cache and application cache, and you need a good architecture. We'll see how to do that briefly. So this is what we're going to review in details with a little demo. So rendering first. Most of the rendering is probably, you can have static site generation, which is great, but it means that every time something is changing on your website, you have to regenerate everything. So it doesn't apply for an e-commerce website with millions of products, millions of pages. Do you imagine if you have to rebuild all your project when a stock is changing? SPA, on the other side, will have bad argument for SPA because it will be bad for SEO. You still have to load the full application at the first rendering. It's not great. Then we have SSR, server-side rendering, which enable HTTP caching. And this is where Remix is great because the Remix approach is progressive. You have the benefits of the server-side rendering, but you also have some benefits of the SPA, or of static site generation, kind of. So for e-commerce project, Remix is really, really powerful. So let's deep dive right away on how to achieve better performances. Because with Remix, you get a lot of performances right out of the box. But what if you are building the 1% project where you need a little bit more? And we're going to talk about HTTP cache using Remix. So first, I built a little bit of a demo for this talk. So using Crystallize, we have a tenant, mentioned that we are building sexy UI. So this is a tenant where I put some donuts. So the donuts are the product we're going to sell. And so you have the variation of those products. You have the product storytelling. If you want to manage the price, you have everything. And you have the developers UI, when you want to get access to the data through the API. So we're going to use those data and running a very simple Remix application. For the first part, it's just a real simple Remix application. One home page, one shop page, which is going to list the product, and one product page, right? And so we're going to use this as an example for this talk. So let's have a look at the code. Pretty easy. We're just going to focus on the route. So we have the home page, which is doing nothing, the shop page, which is loading the product, and the product page, which is loading data for the product. So let's come back to the slide and discuss about HTTP cache. So when we are talking about HTTP cache, we need to make decisions. We need to decide if we want expiration model or invalidation model. Today we're going to talk about expiration model, which means that we are going to use long TTL. We want to achieve a 95% hit ratio. What does that mean? It means that your application will be in cache 95% of the time, while still being 100% dynamic. So for that, we're going to use reverse proxies, or CDN, and we are also going to use browser cache, of course. But on the browser side, because you cannot purge the browser, we're going to use short TTL. So it's short TTL in the browser, long TTL in the reverse proxy on the edge, kind of. So with Remix, we have three situations when it comes to cache. We have the data loading, we have the first page rendering, and the page chunks. I'm going to review that quickly, and then we're going to see it in action in the demo app. So for page chunks, it's actually really easy because they are immutable, right? They're part of the build. They don't change. Once they are in your browser, they will stay in the browser because it's immutable. Cool. Thank you, Remix. When we are talking about the first page rendering, though, if you don't do anything, it's not going to be cached anywhere. You have to tell Remix to add header to the response, to instruct the browser to cache for a certain amount of time. Here it's 60 seconds. Or you can instruct the reverse proxy or the CDN to cache for a longer time. Here, an hour. Also don't forget stale while revalidate. There is a good talk tomorrow about this. I didn't put it in the slide because it was too wide. So then we have the data loading. For the data loading, it's the same things. If you don't do nothing, then there is no cache. So every time, and we will see it in action, every time you click on a page, the browser is going to load the data. So we need a better way, and we need a way to cache it. This is what we're going to do. And we're going to do it right now. So I'm going to come back to this application. I'm going to make sure, that it is loaded. And then we're going to have a look at the code. So if you look at this, for now, there is no header. If you look at the index, there is no header, right? So I'm going to switch to the branch I prepare. At the difference. So now, on my home page, I do a cache header here. I have a cache header as well here, and one for the product. So if I come back to my Remix application and I open the inspector, you'll see that when you load this first page, everything is loaded, right? I'm going to disable this checkbox and do it again. So everything is new. The browser is downloading everything, right? Then I go to the second page. Remix is going to load the chunks that was not downloaded yet on your browser. And if I go to the last page, the product page, again, Remix is going to load the product chunks and the data, of course, right? So if I clean this and I come back to the home page, no data is loaded on the home page, but if I go back to this page, then I have only the data. If I go to the product page, again, Remix is going to load the data. But if you pay attention, you can see that here, it is loaded from the cache. Why is it loaded from the cache? Because we instruct the browser to keep it for half an hour, right? So this is cool. We have cache in the browser. So here I could stop the network, not going to do it, but I could stop the network and the application is still going to work, right? Great. But now the question is, but how do you make it dynamic if everything is in the browser, everything is in the cache on the reverse proxy? Well, to make it dynamic, you need a way to expire this cache in the CDN, right? But how do you do that? Are you going to purge per URL? Are you going to purge a set of URL? Are you going to empty all your cache? This is the question, right? So to do that, actually, you can tag the response. The trick is to use an header, surrogate key if you are using Fastly, or X key if you are using Varnish. And doing this, you can actually instruct the reverse proxy or the CDN to tag the answer. So you can purge based on what you want. So here what I've done is I have product 1, 2, 3, 4, 5. I'm going to instruct the browser and the reverse proxy to keep that in its cache. And when I want to purge this specific product, I can say, hey, reverse proxy, please purge all the response, all the objects that you have in your cache that are tagged product 1, 2, 3, 4, 5. To do that, you need a system. If you are using Crystallize, this is kind of built in. You can actually enable webhooks that say every time you get an order, every time a product has changed, please call this endpoint, and this endpoint will be in charge of purging the cache for you. So this is how you achieve a 95% hit ratio with HTTP cache. When it comes to user specifics, if you are doing B2B, sometimes you can have prices that are very specific to a specific user. How do you do that if you are caching? So there is no magic trick here. You need to bypass the cache somehow because it's so specific to the user that you need something custom. So here, again, Remix comes to help. You can just use fetcher. You get your optimistic UI. You just, load this request after them all to enhance the UI with the specific price. Then we have another optimization, HTTP2 server push. So usually, as a developer, when you are working with localhost. It's not over HTTPS, and so it's not really known. Actually, there is a pull request in progress. So maybe Kent, you've seen it already. But what does it do, HTTP2 server push? It enables you to push resources in the same response at the initial load of the page, right? So we're gonna do that together, so you see that in action. So the trick is, again, using an header. So this one is specific. It has to be linked. So you're gonna say to the server, please push this resource with the response, and the browser, which is also able to talk HTTP2, is going to understand that and load it. Receive it. And to go further, because Remix is actually downloading, the browser is downloading chunks, the first load, you can instruct Remix to send all the chunks right away to the first load, right? So it's really powerful to do that with HTTP2. So I have actually an example for that as well. All right. So we're gonna have a look at what's changed. So in terms of code, not a lot has changed. This is the index. Nothing changed, but we have the link that we are talking about. For the shop, same stuff. We have the link, and we are taking the link from the parent if you are using nested layout or nested route. And for the product, we didn't do anything, but this is just for the demo. And we have enabled what I was talking about, which is a pull request here. So we are going to push through HTTP2 the initial chunks on Remix. So for this, and because it's on top of HTTPS, I have actually some certificate on my local, and I'm using CADI file just to handle HTTPS. So I have a custom domain. So this is on my local. Of course, it's not working. Of course, make serve HTTPS. All right. So this is on my local. I have my Remix app on top of HTTPS, and I also have my Remix app in HTTP. So we're gonna be able to compare. So I'm going to open this one. For this one, I'm going to remove the cache on my browser because, I've downloaded everything already. So my chunks are immutable. They are in the browser already. So I'm removing the cache. I reload the page. And here you can see business as usual. The page is loading. The chunks are loaded. All in parallel. Huh? Thank you, Remix. It's great already. I was telling you, it's for the 1% website where you need even more performance. But can we do better, right? So on top of HTTPS and server push, we're going to do exactly the same, but now you're going to see that the browser is actually, showing you that you are using push, and push, right? Which means, what does that mean? That means the browser is not going to download those files after the page is loaded. It's through the HTTP2 protocol, those resources are sent to the browser on load. So you save a little bit of time, right? So this is HTTP2 server push, and it's kind of free to use that, right? If you have a server, you just enable it, you put the links, and boom. So no reason not to use that. All right, let's come back to the next topic. The next topic, after you're done with HTTP cache and it's all working, you have application cache. So we're not going to deep dive into application cache because you can do a lot, right? Application cache means you can cache whatever you want on your application. I just wanted to provide an example of application cache using eCommerce. It's the stock/inventory management. When you're doing e-commerce, usually you have one warehouse or your garage, and you are selling products, right? Let's imagine we are not selling digital product. So we have 3 different kinds of stock. The stocks that you have in your warehouse, the stocks that has been booked, so they have placed order, and the available stock, which is actually what you are showing on your website. And to get the stock that has been booked, that has been reserved, most projects that I've seen before, they are doing that on the fly. They are fetching all the order that has been placed, they compute the quantity, and then they do the subtraction. That's nice, but it's not performant at all, right? You could definitely have just a property in your system, in your storage, to save this, what we call on hold, and you update it. And the benefit of doing this is when you update it, you update your product variant, and then you trigger everything that needs to be triggered to expire the cache, to expire the application cache, the HTTP cache, to update your index, to do all the action that needs to be done to achieve this 95% of hit ratio. And of course, you don't want to do that on a request, right? You don't want your server to do synchronous things. The more asynchronous that you are, the better. So this is a simple example, but even sending an email is slow. You should not send an email on request. There is no reason to do that. A very simple flow would be you place an order, you have a database insertion, you check the payment somewhere, you send an email, you update the stock, you clean the cache, then you will push the order somewhere in Salesforce or whatever, and then the buyer is receiving the confirmation, right? And this is slow. You don't want that. So the easy trick, the scalable trick, is to use queue. So you just insert the data into your database, you send a message to a queue, and then you manage everything asynchronously. This is how you can scale, basically. So yeah, so to sum up, conclusion, thanks to Remix, you can build very scalable and high-performance website because it relies on HTTP standard. HTTP, you know, it has been around for many years, and you have everything that you need to build really complex and dynamic application using cache. Another trick regarding cache is part of your application. Don't keep cache just for production or staging. Make your local development and your CI using HTTP cache. You can have Docker, Varnish. You can replicate the cache in your CI and on your local. Same for HTTPS. Do that, and you're going to build great project. And of course, asynchronous is key. That's it. Thank you very much. We are organizing React New York. If you want to join, it's on September 9th. So if you have any question, I will be happy to answer them. Thank you.